So, welcome back to a very short video. I've been ill for a couple of weeks, and you might have seen it in the previous video. I was actually on the brink of getting very ill, but meanwhile I have finished up the project, and just recently I have finished the layout, and the schematic is also finished, and all the DRC. So the next thing for me to do was to upgrade to KiCad 7, and that was a breeze. So let's have a quick look at that. And the first thing I notice is that it's really fast. So it was like this. The background images were turned off. And this seems very fast, but nothing unusual yet. But when I turn on background like this, look how fast that came in. So, and if I move the screen around, look how smooth it was. So it was really slow. And let's see some before and after. When you edit something, like for example, we take this edge here, and then I do move it around. Look how fast it is. Even with background image. So I wish I had changed to KiCad 7 a week ago. So it would be so much better. So here you can see earlier clip where I did this, and you can see how sluggish the whole program was. This computer is from like 2011. The CPU is a 2009 model. It's a really slow CPU, but look at this. And it's so quick and fast and smooth and everything. So yeah, so I have gone over all the silk screen to make that perfect as well. All the front mask, all the copper fields, all the DRC. However, when I went to KiCad 7, I got more errors than before. So I will have to attend those, but in just a couple of days I think I will order some prototypes. So yes, now I just have to select the color I need as well. So yeah, there you can see 198. Most of them is just this aperture bridges thing that I didn't understand so well. So yeah, but I also noticed that many of these errors are down at this PLA thing. So if you go here, it's so fast now. It's really nice. Here you can see, I don't know why they are not on both sides here, but let's have a look what it looks like in 3D. I haven't tried 3D here yet, so let's hope it works. Yeah, it works. Oh, that is the same as before, it's slow. But yeah, here you can see the solder mask aperture. Aperture just means openings. It's bridging, yeah. But actually I want that. You don't want a little thing slither between there. It doesn't make any sense anyway, so I will just silence those errors anyway. But yeah, so there it is. Looking at the schematic, it looks about the same here in KiCad 7. However, I noticed something weird going on here. So I hope it's not much around there. It still has the integrity of the schematic. So yeah, so that's about it. So just a short update for you. So I was ill for 1.5 weeks, and I feel better, but I still have a bronchit. I'm not sure what it's called. So hope to see you soon. So I can't really talk much now, so because I'm not alone in this room and someone is sleeping. So a monster behind me. I can't wake, but she sleeps very heavily anyway. So. Okay, we will find out what color we want on that silk screen. Marty on Twitter, he suggested a black core. So the board itself is black, and then a clear solder mask. Yeah, anyway, it looks really cool, and I also would like to see all the traces, even with the solder mask on. So if it's not too expensive, I will have it ordered, or maybe I will be sponsored, so I won't have to pay anything for it. Yeah, so I'm very grateful for that also. Yeah, and I was talking to Arctic Retro also, and he also want to maybe try and build this. So let's see how that works. Anyway, so we need to prototype this and see how this goes. Actually, something I didn't show you for last time was this diode arrays, and you can see them. Actually, I can click one. There you go. So they have the center common, all of them. You can see this 5V thing goes over here. Let's put on some traces here. So actually this one doesn't have 5V. It has yeah, it has 5V, but this network here is ground. So anyway, so the diodes are like connected commonly to ground, and then the other end, or the anode or diode on the other end. So it depends on if it's a common, like here is a common cathode, and on the other end it's a common anode. So yeah, so it looks like they tried to make like a protection circuit, such that it won't go below ground and it won't go too far above 5V. So if you disconnect or reconnect something. So yeah, that might happen if you connect like a joystick. I think some of these, yeah, it looked like this one, for example. It goes to here and it's protected there. But however, this was never done. So these were never like populated. But since they are in the image, like here. Oh, okay, I can just click this one, it will go. No. So, it will go in the foreground. These are in the image, but they are never kinda selected. This is a board. I even have some picture on my phone. There you go. You can see they are not populated, but they are around this connector. And I think it's related to that joystick ports they wanted to protect. I don't know how many times as a kid I touched that with my fingers. I remember my parents had like this carpet from wall to wall, and one time I had some really hard static discharge, and it really hurt. You know, some are worse than others. And the CIA was killed, and I had to hand in the computer. I didn't notice it at once, but I think it was a joystick port 2 or something, or the other joystick port had to be, it was no longer working properly, and some of the keys didn't work and such. So yeah. So yeah, that was back in the day, so yeah. Anyway, I have to go now, so talk to you very soon. Bye bye.